Welcome friends to this new session of soil science and technology, and in this session we will continue the soil taxonomy and classification, and I'll we'll discuss different aspects of soil taxonomy, what are the important factors it considers for classifying the soils, and then we will be discussing what are the important surface soil features, subsurface soil features, and then what is soil moisture regime and what is soil temperature regime, and so on and so forth. So, let us start from where we left in the last lecture. So, in the last lecture we discussed about the different hierarchy of the soil taxonomy. So, as I have told you that soil taxonomy is basically combination of 6 different levels starting from series, family, subgroup, grade group, suborder and order, and we can classify any soil using this hierarchical system. So, this this is the major or stark difference from other or previously described genetic and morphogenetic system, that you can describe or you can classify any soil based on measurable soil property. Just like you can classify some people, a group of people into several classes based on their hair color, based on their height. So, these are measurable soil properties. Similarly, soil taxonomy uses some measurable soil properties to classify soils. So, what are the major features of soil taxonomy? Well, soil classes were defined in terms of present soil properties, and all such properties were considered which affect soil genesis or the outcome of soil genesis. So, in this system it is not neglecting soil genesis, it is also considering soil genesis, but in terms of some measurable soil properties, and the nomenclature were made using Greek and Latin words, and a new category called subgroup was then added to define the central concept of the grade groups. And remember that this system is much more easy to remember than than earlier genetic and morphogenetic systems. So, before discussing the orders, let us first discuss the important diagnostic horizons. Remember that soils are described in terms of some visible and measurable properties, and also based on the presence or absence of certain features in their profile. So, based on certain characteristics, their surface horizon or subsurface horizons are differentiated, and we will discuss them one by one. So, diagnostic horizons are basically of two types, one is called surface horizon, another is subsurface horizon. Now, another name of surface horizon is called epipedon, and the other name of subsurface horizon is endopedon. So, there are several 8 epipedons and 20 endopedons, each of them differing in their own characteristics, and based on whether those epipedons or endopedons are present in a particular type of soil, we classify them using the soil taxonomy. So, that is the use of these diagnostic horizons. So, let us see them one by one. So, as you can see here, I have listed here diagnostic surface horizons or epipedons. You can see there are 8 different diagnostic surface horizons: molic, umbric, ochric, pholistic, histic, melanic, plagian and anthropic. Above these molic, umbric and ochric, I highlighted them in red because they are found in more more frequency than others. Okay. So, let us discuss them one by one to know their individual properties. So, let us start with the Maulic epipedon. So, this is the picture of a Maulic epipedon. The most diagnostic feature of this Maulic epipedon is dark color and is a thick layer. So, you will see that there is a dark color thick surface layer, obviously that is a Maulic epipedon. So, it must contains more than 1% of organic matter, and it should be dark in color, and its structure, we will discuss structure in the next classes. Structure should be neither massive or hard, and it should have a base saturation greater than 50%. That means, base saturation means it should have the dominance of basic cations like sodium, potassium, calcium and magnesium should be more than 50%, or percent base saturation should be more than 50%. The other way to represent percent base saturation is the percentage of basic cations among all the cations which are present into the soil. So, when the percent of base saturation goes beyond 50, that is an important feature of Maulic epipedon, and these Maulic epipedon remains moist for more than 3 months of a year. So, this is an example of a Maulic epipedon. Let us see what is the next. The next one is called umbric epipedon. Now, umbric epipedon is also similar to Maulic, but with less than 50% of base saturation. It is also looks like Maulic, it is a dark color, thick, and it is been moist for more than 9 months of a year. So, that is the difference between Maulic and umbric. Third one is ochric. Now, remember that this ochric epipedon is light in color, as you can see it is light in color, and it contains less than 1% of organic matter. Obviously, when there is a high organic matter, there will be dark in color. So, it contains less than 1% of organic matter. It is hard or very hard when dry, and it do not qualify for any other horizon. So, this is why it is called ochric epipedon. Pholistic epipedon. Now, pholistic epipedon is basically layer with high organic matter as saturated with water for less than 30 days, as you can see. So, it contains high amount of organic matter, and it has low bulk density of less than 0.1 gram per cc or megagram per meter cube, or organic carbon of 8 to 16% depending on the clay content. So, this is pholistic epipedon. Another is hystic epipedon. As the name suggests, hystic comes from some tissue. So, it is organic in nature. So, it contains more than 20 to 30%. Remember that it is a high content of organic matter. So, it contains 20 to 30%, greater than 20 to 30% of organic matter depending on the clay, and greater than 30 days water saturated. So, it remains saturated for more than 30 days period, and it is less than 30 centimeter thick if drained and 45 centimeter thick if not drained. So, these are the characteristic of hystic epipedon. Again, it is dark in color, it contains huge amount of organic matter. The next one is called melanic epipedon, and melanic epipedon is again a thick black horizon with high organic carbon which is greater than 6%. And it is generally found in Andic soil, generally associated with Andic properties, that means in volcanic regions or volcanic soils you will see that. So, this is called melanic epipedon. The next one is called Plagian epipedon. Now, Plagian epipedon is a man-made horizon which is more than 50 centimeter thick, and it contains greater than 0.6% of organic matter, and it remains moist for 3 months. As you can see here, it is a Plagian epipedon, and obviously this Plagian epipedon is it is made due to human interventions. Now, the next one is called anthropic epipedon. Now, anthropic epipedon is also similar in color to that Maulic and Umbric. So, it is dark in color, and remember that these anthropic epipedon is developed by human or altered or transported materials with artifacts and human litters. So, again it is kind of anthropogenic in nature, and that is why it is called anthropic. The name itself suggests due to the human interventions. So, this surface horizon basically forms due to human alteration or transportation of materials with artifacts and human litters. So, this is called anthropic epipedon, and remember that this anthropic epipedon is less than 25 centimeter in thickness. So, we have covered the anthropic epipedon. Let us see how we can segregate this histich, Maulic and Umbric and ochric. So, as you see here in this graph, let us see the parent material is the starting point of soil formation, we already know that, and in the y axis we are putting the organic matter accumulation. So, as the soil will develop from the parent material after certain period of time when the vegetation is established, and after a certain period of time you can see here T max is given 3000 years. So, you will see the organic matter accumulation will continuously increase and it will reach up to a plateau, and at this time we will be calling this as a Maulic or Umbric. As you know, both of them are high in organic matter. However, histich epipedon, which contains more than 20 to 30% of organic matter, will be showing more organic matter accumulation, and ochric, which is basically light color epipedon, will show less amount of organic matter. So, that is how this Maulic and Umbric stands in between histich and ochric epipedon. So, these graphs give you a basic idea about how we can segregate this ochric and histich from Maulic and Umbric, and all of these are considered as important surface soil horizon, based on which soil taxonomy differentiate or classify different soils. Now, let us see what are the diagnostic subsurface horizons. We have covered surface horizons or epipedons. Now, let us see the subsurface horizons. These subsurface horizons, the other name of this subsurface horizon is endopedons, and remember that these endopedons are developed based on the formation, translocation and transformation of clays, organic matters and oxides. So, when clay, organic matter and oxide translocate from one part of the soil to another part, and when it transforms from one form to other form, then they create these diagnostic subsurface horizons or endopedons. So, there are 20 endopedons. I have given here names. So, starting from egric, then albic, then anhydritic, then argillic, calcic, cambic, duripan, fragipan, glossic, gypsic, candic, natric, oxic, petrocalcic, petrogypsic, placic, salic, sombric, spodic, sulfuric. All these are important subsurface horizons or endopedons. Remember that some of them, a considerable amount of subsurface horizon occurs due to alluviation or deposit of alluviated materials from upper horizon to lower horizons, which I have already covered in our soil formation lecture. So, I have highlighted the, I have red texted these albic, argillic, candic, oxic and spodic because they are occur in the nature in higher frequency. So, let us discuss them one by one. So, let us first see what is egric horizon. Now, egric horizon is basically the horizon which forms due to which forms under the plough layer as dark lamellae. So, obviously, this egric horizon occurs due to the plough action and it occurs below the plough layer, as you can see. So, it is an important subsurface horizon or endopedon which occurs due to human action. Second is albic horizon. Now, albic horizon is basically an alluvial horizon. Now, I have already told you what is alluviation. Alluviation is movement of clay and other materials from upper part of the soil profile to relatively lower part of the soil profile. So, this is called alluviation, and this alluviation, this albic horizon showed alluvial horizon, and it is greater than 1 centimeter in thickness and formed by light colored sand and silt. So, as you can see, this is an example of this subsurface albic horizon, and here we are putting in the x axis CEC and in the y axis we are putting the depth of centimeter. So, obviously, at the top there will be ochric epipedon followed by albic horizon. So, obviously, at the below the ochric horizon there is an albic horizon followed by candic horizons. So, again all albic horizon is an important alluvial horizon or subsurface horizon. All right. Now, next one is called anhydritic horizons. This horizon basically is greater than 15 centimeter in thickness and with 5% or more calcium sulphate anhydride. The other name of calcium sulphate is anhydride. So, this horizon basically contains more than 5% of calcium sulphate, and it shows different color hue, chroma and values. Its hue is 5Y, which is a dominant spectral color, chroma is 1 or 2, which is purity of the color, and value is 7 or 8, which is degree of darkness or lightness. So, this is an example of anhydritic horizon. The next one is called argillic horizon, and this is very important one. Argillic horizon is basically, you can see in B horizon. Now, it is clay enriched. Remember that it is enriched in clay. So, clay enriched B horizon with clay skins or clay films, and clay content varies with the clay of the layer above, and obviously it is greater than 15 centimeter thick and at least 1/10th of upper horizon depending on the texture. So, in this picture obviously the lowermost part is argillic horizon, which shows higher accumulation of clay which has been alluviated from upper horizons. So, alluvial clay or alluviation of clay into argillic horizon, it again can be differentiated into three this argillic horizon can be further differentiated into three subsurface horizons. One is called natric horizon, another is glossic horizon, another is candic horizon. Now, this natric horizon is basically composed of alluvial clay, but with a sodium enrichment. When there will be alluviation of clay and simultaneously there will be degradation, we will call it glossic endopedon, and finally, when there will be argillic horizon, but with an oxide clays, then we will term it as candic horizon. So, these in other words, these natric horizon, glossic horizon and candic horizon occurs from the alluviation of the clay, or this is basically these three subsurface horizons or endopedons are modifications of argillic horizons. The next is calcic horizon. Calcic horizon basically shows alluviation of calcium carbonate as the name suggests, it is more than 15 centimeter in thickness and it is basically cemented, and it contains 15% or more calcium carbonate, and it contains 5% or more calcium carbonate than that of underlying layer. As you can see, the name, this in this soil profile, this layer is basically the calcic horizon and it is white in color, and this is very important subsurface horizon. So, cambic horizon is basically a color or structural B horizon formed due to physical movement or chemical weathering, and it is generally greater than 15 centimeter in thickness. The next is called Duripan. Duripan is again a subsurface horizon which is cemented by silica, and it is air dry beds or air dried soil which basically do not slake in water, but in hot potassium hydroxide. So, you will see that this is Duripan and these are highly cemented by silica, and these are very dry and they do not slake in water, but they can be slaked in the contact of potassium hydroxide. Another one is called Fragipan. Now, Fragipan is again greater than 15 centimeter in thickness, and it is brittle when moist and hard when dry, and air dry fragment generally slake in water. So, this is an example, this is basically an example of Fragipan. The next one is glossy horizon. As I have already told you, it is a modification of the glossy horizon, as we have seen in the previous thing. It is the degraded argillic horizon. So, similarly, this glossy horizon is a remnant of argillic or candic horizon from which clay and free iron oxide were removed. So, again it is a modification of argillic horizon, and generally it is greater than 5 centimeter in thickness. The next one is called gypsic horizon. Obviously, it is greater than 15 centimeter in thickness and shows the accumulation of gypsum, and this horizon basically contains higher gypsum content, at least 5% more gypsum content than that of the underlying soil or other upperlying soil horizons. Now, candic horizon, remember that the candic horizon is mainly composed of low activity clays, or in other words, this candic horizon is a modification of argillic horizon. So, it is basically an argillic horizon with or without clay skins, and it is basically dominated by low activity clays, and it has a cation exchange capacity of less than 16 and effective cation exchange capacity of less than 12 centimole proton per kg of clay. So, it is basically can be found basically red and lateritic soil, and it is dominated by low activity clays. Natric horizon is an argillic horizon which shows the dominance of sodium with some prismatic and columnar structure. We will discuss structure later on, and it contains exchangeable sodium percentage greater than 15. So, this is an important property, and it contains more exchangeable sodium and magnesium than that of calcium. So, as you can see, this is an this is a natric horizon which is showing accumulation of sodium, and these are having columnar structure. Oxic horizon is basically greater than 30 centimeter thick in thickness and high content of low charge minerals, and it has got CEC and ECEC less than 16 and 12 centimole proton per kg of clay respectively, and it contains no argillic horizon, and it contains less than 10% weatherable mineral in fine sand. Next one is petrocalcic horizon. It is basically a hard greater than 10 centimeter thick calcic horizon, and due to the presence of these subsurface horizons, root of the plants cannot penetrate into the soil. So, this is bad or this is harmful for proper growth of the plant. So, this is called petrocalcic horizon. Another is petrogypsic, as the name suggests, again it is a strongly cemented greater than 5 millimeter thick gypsum horizon, and it is similar to petrocalcic horizon, instead that is it is dominated by gypsum. Classic horizon, it is again a very hard pan, and it is very hard pan and cemented by iron and manganese. So, classic horizon is basically dominated by iron and manganese. Salic horizon, as the name suggests, it is a salt enriched horizon which is having thickness of greater than 15 centimeter, and it has the electrical conductivity of saturation extract greater than 30 decisiemens per meter. Sombric horizon, it is an alluvial humus horizon with color and base saturation of umbric horizon. If you remember the umbric horizon, it has high, it is dark in color, but base saturation is low. So, similarly, the sombric horizon is an alluvial humus horizon with color and base saturation of umbric epipedon. Finally, spodic horizon, which is an alluvial horizon of free sesquioxide and organic matter. Sesquioxide is basically combination of iron oxides and aluminum oxides, and this spodic horizon basically shows accumulation of iron oxides and aluminum oxides and organic matter, and it contains greater than 85% spodic material, and it is generally greater than 2.5 centimeter in thickness. Sulfuric horizon, accumulation, it shows accumulation of sulfur minerals due to the seawater intrusion in India. In the Kerala region, you will find this type of sulfuric horizon in Kari or Pokali soils, and the pH of the soils is very low, which is less than 3.5. So, in a nutshell, you can see in this picture the different surface and subsurface horizon. Here you can see surface ochric epipedon and subsurface albic horizons, spodic horizon, and below that there is some parent material and glacial outwash. So, in this session you got an idea about what are the important surface diagnostic horizon and subsurface diagnostic horizons. So, in the next session we will be discussing about soil moisture regime, soil temperature regime, and 12 different soil orders. Thank you very much.